Avicena demonstrates first microLED-based transceiver IC in 16 nanometers FinFET CMOS for chip-to-chip. Avicena, a privately held company headquartered in Sunnyvale, California, is demonstrating its light bundle multi-TBBS chip-to-chip interconnect technology at the European Conference for Optical Communications, ECOC, 2023 in Glasgow, Scotland. Avicena's microLED-based light bundle architecture breaks new ground by unlocking the performance of processors, memory and sensors, removing key bandwidth and proximity constraints while simultaneously offering class-leading energy efficiency. As generative AI continues to evolve, the role of high bandwidth density, low power and low latency interconnects between SPUS and HBM modules cannot be overstated, says Chris Visner, VP Sales Marketing of Avicena. Avicena's innovative light bundle interconnects have the potential to fundamentally change the way processors connect to each other and to memory because their inherent parallelism is well matched to the internal wide and slow bus architecture within ICs. With a roadmap to multi-terabit per second capacity and sub-PJ/bit efficiency, these interconnects are poised to enable the next era of AI innovation, paving the way for even more capable models and a wide range of AI applications that will shape the future. Light bundle ASIC in 16 nanometers FinFET CMOS with transferred microLED and PD array and parallel electrical interface. Artificial intelligence, AI, is driving an unprecedented surge in demand for compute and memory performance, driven by applications like ChatGPT based on large language models, LLMs. These sophisticated models have an insatiable appetite for computing power and fast memory access, resulting in an urgent and growing demand for much higher density, low-power interconnects between graphics processing units, GPUs, and high-bandwidth memory, HBM, modules. Today, HBM modules must be co-packaged with GPUs because the GPU memory electrical interconnect is limited to just a few millimeters in length. Conventional optical interconnects based on VCSELs or silicon photonics, CPH, promise to extend the interconnect reach. However, they are challenged by the power, bandwidth density, latency, and cost requirements. By contrast, Avicena's microLED-based light bundle interconnects provide much lower power and latency, much higher bandwidth density, and can achieve very low costs. About the technology. Today's high-performance ICs use SerDes-based electrical interfaces to achieve adequate off-chip density. However, the power consumption and bandwidth density of these electrical links degrade quickly with length. Conventional optical communications technologies developed for networking applications have been impractical for interprocessor and processor memory interconnects due to their low bandwidth density, high power consumption, and high cost. The typical need for external laser sources, ELS, with CPH increases complexity and cost. By contrast, the light bundle interconnect architecture is based on arrays of innovative GaN microLEDs that leverage the microLED display ecosystem and can be integrated directly onto high-performance CMOS ICs. Each microLED array is connected via a multi-core fiber cable to a matching array of CMOS-compatible PD'(S). We have previously demonstrated microLEDs transmitting at MGT, 10 Gbps per lane and a test ASIC in a 130 nanometers CMOS process running 32 lanes at less than 1 PJ/bit, says Bardia Pazishki, founder and CEO of Avicena. Now we are bringing up our first ASIC in a 16 nanometers FinFET process with over 300 lanes and an aggregate bandwidth of over 1 Tbps bidirectional at 4 Gbps per lane. The ASIC measures less than 12 and contains the circuitry for the optical TX and RX arrays, as well as a high-speed parallel electrical interface and various DFT, DFM functions like BERT, loopbacks, and open-eye monitoring, OEM. All key ASIC functionality has been verified and we are currently working on yield improvements for manufacturing scalability. In the future, the modular nature of the light bundle platform will enable interconnects with high bandwidth density of multi-Tbps per in advanced CMOS process nodes. The low power, high density, and low latency of light bundle is well matched to chiplet interfaces like UCI, OpenHBI, and BO, and can also be used to enhance system architectures that are limited by the reach of existing compute interconnects like PKI, CXL, and HBM/DDR/GDDR memory links.